Okay, so this question says two bodies, X and Y, are heated by the same flame for the same time. So we're going to have X and we're going to have Y. And we're going to have a flame that is going to be heating them for the same amount of time. It says that X has twice the mass of Y. So the mass of X equals to the mass of Y. And it says, and half its specific heat capacity. So the specific heat capacity of X equals half the specific heat capacity of Y. Calculate the ratio of the temperature rise of X, the temperature rise of Y. Well, what I would interpret this, where it says it has the heated by the same flame for the same amount of time, is I would take that to tell me that the heat of X and the heat of Y would be the same. So we're going to take our equation for specific heat capacity, which is MC delta T, and we're going to just solve that for delta T, which would be Q over MC. So we want to solve for that in terms of X and Y. So the change in temperature of X would be Q, and I'm going to put everything in terms of X then. So this would be the mass of X and the specific heat capacity of X. So I'm going to rearrange these then to solve for Y. So the mass of Y is going to be half the mass of X, and the specific heat capacity of Y is going to be 2 times the specific heat capacity of X. So in terms of the change in temperature of Y, this is also going to be Q, and this is going to be the mass of Y, which is the mass of X divided by 2, and the specific heat capacity of Y, which is going to be 2CX. Those 2's are going to cancel out so that I can then say the change in temperature of Y is going to be Q divided by MX times CX. So if I take the ratio then of the change in temperature over X and the change in temperature over Y, that's going to be Q MX CX over Q MX CX. And so that is going to just come out to be a value of 1 when we look at their ratios.